Hello everyone, my name is Mario Duenas and this is my lab report for Lab 1 in Physics 2211. In this experiment, our objective was to observe an object at the same speed without changing direction. The object that my group chose was a soccer ball. This object is in relation to the position versus time graph model and also with the velocity update formula. The position update formula could also be used, but the velocity update formula makes more sense in this setting. Additionally, the idea of net forces is also needed to construct a free body diagram and observe why net force is 0. Throughout this experiment, we used both Tracker and GlowScript to record our data. At first, we used Tracker to record the positions of the soccer ball for every time frame in the video we took, next to a meter stick. Then, using the data table produced by this application, we try to replicate it in a predicted model through GlowScript. In GlowScript, we used the Lab 1 starter code, and then we edited it in order to try and replicate our graph. Briefly, we found out that constant velocity is shown through slope on a position versus time graph, which is supported by our model since our predicted model in GlowScript has the same graph as our findings from Tracker, proving that a net force of 0 results in constant velocity in the system. On the following slide, I have made a free body diagram showcasing the forces acting on the soccer ball in this experiment. In the y direction, we have already concluded that net force is equal to 0 because normal force is equal to the force of gravity. But in the x direction, we have concluded that the force applied is equal to the friction while the ball is rolling. Of course, given more time, this friction would eventually overpower the force applied, making the ball roll to a stop. Using this and the velocity update formula, we have concluded that Vf is equal to Vi since net force is 0. This will negate the F net over m times delta t, making them equal to each other. Of course, if the axes were swapped, then the velocity would also have a negative or positive sign depending on what it was before. This would mean that the sign would be opposite and the line produced on the graph would go this separate way. The following slide is going to be the video we took to put in Tracker. Once we put this video in Tracker, we used the given tools to try and track the position of the ball at the time frames of the video. For this, we needed a measuring tool to calibrate the video, and we used 0.5 meters in order to do so. Then, we tracked the position of the ball and concluded that the ball moved to the left of the screen each time a time frame passed. Using this, we used the data table provided by Tracker and then exported it to Excel, in which we made a chart in order to graph the observed position versus time and also sees the slope of the line. After that, we used the Lab 1 starter code to try and replicate the findings we found in Tracker. For this example, we started time later on because in the video, the ball rolled later on. We started time at 0.767 seconds, and then we put the time frames at 0.01 seconds. Afterwards, we set Fnet equal to 0 since velocity was constant and plugged in the position update formula as well as the velocity update formula without Fnet. After that, we got the graph provided by GlowScript, and then we used the data table under that graph in order to make a graph of our own in Excel. This graph was later used to combine it with the Tracker graph and compare our lines with their negative slopes. For our results, we plotted both lines we found through Tracker and GlowScript and plotted it onto one graph. The orange dots represents the Tracker graph, while the blue line represents the GlowScript line. The GlowScript line is more linear since it's a predicted measurement, while the Tracker graph, as you can see, caves a little downward and then goes back onto the trend line. Overall, we could say that our experiment was largely successful as we were able to predict the observed position over time. Some errors that could have occurred was a slanted roll. Our soccer ball rolled slanted towards the end of the experiment, and also real life friction, as friction will not always be equal to the force applied and will somewhat slow down the ball. Additionally, the camera frames do not align with the frames used in GlowScript, which is why GlowScript has a more accurate measurement. If we made the ball roll to the right, our graph would have been inverted over the horizontal axis, giving us a positive slope. Other than this, our experiment was largely successful and proved that net force of 0 results in a constant velocity.